Hi everybody, we are here to look at this kind of energetics question whereby we involve some temperature change, okay? So let's look at the first part first. So they say standard enthalpy change of combustion, okay? So the definition you must know, right? So the key idea of this standard enthalpy of combustion is that the energy release when 1 mole of substance is completely burnt. Okay, in excess oxygen under standard conditions. Okay, so the main thing is that the amount of energy release. Okay, take note of this, and this kind of question you have to score, okay, because it's really free 2 marks. Okay, but the main thing I want to discuss over here is how to calculate the standard enthalpy change of combustion of ethanol over here. Okay, so first of all, we answer part by part. So they talk about the equation including state symbols. Okay, so for the complete combustion of ethanol, so remember the main idea is 1 mole of substance being burned. The 1 mole is the ethanol. Okay, so let's settle the equation first. C2H5OH. Okay, so this is a liquid plus oxygen gas produce carbon dioxide gas and H2O liquid. Okay, so first of all you need to balance the carbon first. Okay, balance the carbon first, so we put a 2, and then for the hydrogen we put a 3 over here. So the total number of oxygen on the right side is actually 7, right? 4 plus 3, and over here minus 1, so 6, so we put 3. So this is the first part, okay, for part 1. Okay, and then let's use the data over here. So the data given over here to calculate the standard enthalpy change of combustion of ethanol, right, for part 2. So of course you must know the formula, right? So remember, triangle H, standard conditions of combustion, okay, equals to Q over number of moles of ethanol. Okay, so remember, it's always the heat release. So for this case, it's confirmed a negative value, okay, because it's exothermic. So the heat release is actually using the formula mc delta deta, right? So if you learn physics, it's easier, but if you never learn physics, you must know as well. So for this case here, right, so it's mc delta deta, and then we get values. We get the values from the table, and this one here is the moles. Okay, so let's check out the mass. So for chemistry, the mass is always the water being burned, right? So over here it's 100 grams, or sometimes they link to cm cube because taking density to be 1 gram per cm cube. So 100 grams multiplied by 4.18, which is given, and then the temperature difference will be 48 minus 28. Okay, and then you divide by the number of moles of ethanol or fuel being burned, right? So it's actually 0.30 grams divided by the mR of ethanol. Okay, and remember your final answer, right? Your final answer must be a negative value. Okay, because remember this is combustion. Combustion is actually hot or exothermic, right? So this is the process. So I repeat again, not difficult. First of all, you need to use the formula here. Okay, this is the formula, and then Q is MC delta liter, okay, divide by moles of fuel. Please remember, okay, moles of fuel being burned, because that is the one that is driving the temperature to go up, right? Okay, so you calculate yourself, and then remember this method, and this is one kind of question that will be tested in the exam. Okay, so I'll see you at my next video. Okay, goodbye.